Here's a quick video on lesson 81. It was just a review lesson on arithmetic and geometric sequences, identifying which one we're dealing with. So here's the idea. You have recursive sequences and explicit sequences. Explicit, like as stated here, those are the ones that are nice to plug into if you need to find a certain term, like for instance, find term 45. Those are the ones you're going to want to use. Explicit are the ones that are on your reference sheet. It's these two here. So that's what your reference sheet looks like. You got a copy from me in class. These are the two. So arithmetic sequence explicit is here, and geometric sequence explicit is here. Now you might be asking yourself, why is there no recursive? Where is that written? Well, recursive isn't written anywhere. You have to memorize it because the idea for recursive is pretty simple. Recursive has two parts to it. Recursive has a sub 1 is equal to something, telling you what the first term is. And then there's a rule that always starts off the same. A sub n is equal to a sub n minus 1. And then you just tell whatever is happening. So for instance, if I'm looking at this sequence here, -2, 3, 8, 13. I need to see, is this arithmetic or is this geometric? I need to basically ask myself, am I adding and subtracting or am I dividing, multiplying? So let's see. If I went from -2 to 3, that would be plus 5. From 3 to 8 would also be plus 5. 8 to 13 would also be plus 5. So it seems like we have a common difference, and that rule is plus 5. So here, the first term is -2. Any term is equal to the term before it plus 5. That's the recursive for creating this sequence. That's it. It's that simple. The explicit is going to be the one that we pull from the reference sheet. But let's take a look at these and see which kind of sequence we're dealing with. 2, 6, 18, 54. So let's see. From 2 to 6 would be plus 4. From 6 to 18 would be plus 12. So we must be multiplying, because if we were adding, it would be the same number every time. So let's see. I know that to get from one number to the next, I'm multiplying by r. Whatever the ratio is, I'm multiplying by that times r. So I could say, for instance, that 6 times r is equal to 18. Divide both sides by 6 to get r by itself. 18 divided by 6 is 3. So that's r. Now let's take a look. This is geometric because it is multiplication. The geometric sequence is this one. So a sub n is equal to a sub 1 times r raised to the n minus 1 power. So here's the template. A sub n is equal to a sub 1 times r to the n minus 1 power. The two things I need to be able to plug in are a sub 1 and r. A sub 1 is 2. Well, that's easy. First term is 2. R is, we already found that, 3 to the n minus 1 power. That's the explicit notation for that. Let's do one more where we have to plug in the explicit sequence notation to find term 45 of this sequence. So let's see, it's going to be two parts. Find the sequence, then plug in 45. So from 6 to 2, this would be minus 4. 2 to -2 is also minus 4. Okay, cool. So we're just subtracting 4 every time. Now this is arithmetic. What that looks like is this. A sub n is equal to a sub 1 plus n minus 1 times d, which is the common difference. And here are the two I need to find. A sub 1 and d. A sub n is equal to, well, the first term is 6 plus n minus 1, and the difference is the one that we already found. What are we doing every time? Subtracting 4, so that's times -4 at the end. This is the explicit sequence notation. Now, if I want to find the 45th term, I'm going to have to plug 45 in for n. So 45th term, that means n equals 45. So let's plug in. A sub 45 is equal to 6, forgot the plus 45 minus 1 times negative 4. And I can actually plug this right into my calculator, as long as I do it the way that I have it right here. 6 plus 45 minus 1 times negative 4. Enter. Negative 170. So A sub 45 is equal to negative 170. Okay, and that's it. So if you aren't sure about how to find a ratio, go back to the example that I just did to find this on question number 2. If you aren't sure the difference between explicit and recursive, go back to the beginning. I'm going to give you one example of something that happens a little wacky down here on question number, let's say 8. Okay, so 8. They want to use the explicit to find term 64. So this is 5 to 20 would be plus 15. Well, this isn't plus 15. So I don't think that's what we're doing. This is plus 60. I think it's multiplication. So 5 times what would be 40, would be 20, I mean. So 5 times r would equal 20. Divide both sides by 5. And I get that r is equal to 4. Okay? So here's the general notation. A sub n equals a sub 1 times r to the n minus 1. The first term is 5. So I get a sub n is equal to 5 times 4 to the n minus 1. And that's the notation. If I go to plug in for term 64, this is going to get really out of hand. N equals 64. So A sub 64 is equal to 5 times 4 to the 64 minus 1 power. I'll take that into my calculator. 5 times 4 raised to the 64 minus 1 power. Enter. 4.25 E38. So 4.25 E38. That's the calculator said. The technical answer is 4.25 times 10 to the 38th power. What that means essentially is that the number we're dealing with has the decimal place moved over this way 38 times. So we're looking at this number, 425 and 36 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. And at this point, you can probably figure out why your calculator didn't display this number in a normal-looking way, because it doesn't have enough space to, because a TI 8384 computer chip can't handle this many. Okay, so either of these would be totally fine, but you won't get a question like that on the test, so either way, you'll be all right. Practice some of these. I recommend 10. Good luck.